Dear students, today we are going to calculate the relativistic correction, that is the relativistic correction to the hydrogen atom due to relativistic effect. Although the relativistic effect in hydrogen atom due to the motion of electron is small, but it can still be detected by some spectroscopic techniques. So the relativistic correction to the kinetic energy of electron, it can be written as like T is equal to P square C square minus ME square C4 into under root minus ME into C square. So we can expand this relativistic kinetic energy of electron up to P power 4. So here we will make some expansion, P square C square minus ME square into C4 minus ME C square. So it's equal to P square divided by 2ME minus P power 4 divided by 8ME cube into C square plus up to so on. So we will ignore the higher term, only we will take up to P power 4. So when we include these values into the total Hamiltonian of hydrogen atom, so I can write the Hamiltonian equation for hydrogen atom. So it's Hamiltonian, it will be equal to total Hamiltonian for hydrogen atom is H is equal to P square divided by 2ME minus E square over R minus P power 4 divided by 8ME cube into C square. So the first two terms, that is the first term represents the kinetic energy of hydrogen atom, and the second term here it represents the potential energy of hydrogen atom. So these two terms represents the Hamiltonian, unperturbed Hamiltonian, and this one term. So this last term it represents represents the relativistic correction. So this is the relativistic part of Hamiltonian of the hydrogen atom. So I can write it like HR. So here the HR is equal to minus P power 4 divided by 8 ME cube into C square. So the total Hamiltonian for hydrogen atom, which is the combination of unperturbed Hamiltonian plus due to the relativistic part of the Hamiltonian. So what we will do now we need to apply the perturbation theory in order to calculate the energy correction due to relativistic effect. So now we will apply the perturbation theory. So according to perturbation theory, the first order correction to energy, first order correction to the energy, it is equal to, I can write the first order correction to energy E1R, that is energy due to relativistic correction. This subscript R represents the energy due to relativistic effect and is equal to NLJ into MJ into HR NLJ into mj. So this is the first order correction to energy. Now I will put the value of relativistic Hamiltonian. So it will be equal to NLJ mj into P4 NLJ mj, and is equal into 1 over 8 me cube into c square. So here I need to calculate the value of p power 4. So what we will do in order to calculate it, I will put the value of p4. So for this one I can write it, the Hamiltonian of hydrogen atom is equal to p square divided by 2me minus e square over r, and it can be written as like p square will be equal to 2me into h plus e square divided by r. So I have to calculate the p power 4. So by squaring it I can write like p power 4 is equal to 2me4 into h plus e square over r into square. So now I will use this value of p power 4. Now putting this value, I can write the NL P4 into NL. This will be equal to 2me into square into NL h plus e square over r square into NL. So now I can further simplify it, and I can write it like 2me square into NL h square into NL plus NL into 2h e square 2h e square over r into NL plus, I can write like NL into e square e power 4 over r square into NL. So I can open the square, h plus e square over r, it will be equal to h square plus 2h e square over r into e power 4 over r square. So further I can split this term and I can write it like 2me square into NL h square into NL plus NL into h e square over r into NL plus NL into h e square over r into NL plus NL into e power 4 divided by r square into NL. And further, as you know that whenever we apply the Hamiltonian on any state NL, and in return we get the energy and NL, energy eigenvalue, as Hamiltonian is the energy operator, its corresponding value is the energy. So in the above equations here I can replace the Hamiltonian by its eigenvalue, so I can simplify this equation. So the equation will be now NL p power 4 into p power 4 and L, it will be equal to 2me square into en square plus en into nl e square over r into nl plus en into, again I can write it like that, en into nl e square over r into nl plus, okay, I can write it here, I can write it like this one, plus en into nl e square over r into nl plus nl into e power 4 over r square into nl. So as the value of 1 over r and 1 over r square, so we have already calculated these values in our lecture of spin orbit interaction part 2, so you can go to that video in order to check the value of 1 over r and 1 over r square. So here I will write the calculated value of 1 over r and 1 over r square from our that lecture. So these values are equal to nl into r power minus 1, that is 1 over r, is equal to 1 over n square a naught, and the value of nl into r 1 over r square into nl is equal to 2 divided by n cube into 2l plus 1 into a naught square. So by inserting the value of 1 over r and 1 over r square, our equation will be, it will be equal to nl p power 4 into nl, this will be equal to 2me square, 2me square into en square plus 2en into nl into e square over r into nl plus nl into e power 4 divided by r square. So now I can insert the value of 1 over r and 1 over r square. So this will be equal to 2me, and I can take the en as a common, en square as a common, and so it will be equal to 1 plus, it will be equal to 1 plus 2 e square over en into, and value of 1 over r is equal to 1 over n square a naught plus e4 divided by en square into 2 divided by n cube into 2l plus 1 a naught square. So again I can simplify this equation by making the sum replacement. So as we know that en is equal to minus e square divided by 2a naught n square, and a naught is equal to s square divided by me into e square. So we will make these two replacements into the above equation to further simplify it. So I can write it like so by making this replacement, NL into p power 4 and L is will be equal to 2me into En square into 1 plus 2e square divided by, here I will put the value of En, and it will be equal to minus e square divided by 2a naught n square multiplied by 1 over n square a naught plus it will be equal to e power 4. Over here I will put the value of e n square, so it will be equal to e power 4 divided by a naught square 4a naught square into n4 multiplied by 2 divided by n cube into 2l plus 1 a naught square. So I can write it like 2me e power n square into, it can be written as like 1 plus 2e square divided by minus e square into 2a naught n square divided by n square a naught plus, I can write e power 4 divided by e power 4 multiplied by 2 into 4 a naught n power 4 divided by n cube into 2l plus 1 a naught square. So but I can cancel out these values, n cube by n4 a naught square by a naught and e square by e square n square a naught into a naught. So the remaining values, simplified value will be equal to 2me e power n square into 1 minus, I can write it like 1 minus 4 plus 8n divided by 2l plus 1, and further by simplifying I can write it will be equal to nl p power 4 into nl, it will be equal to 8n divided by 2l plus 1 minus 3. Okay, it will be equal to 2l plus 1 minus 3 into me4 into me en square. So again I can put the value of en square, so this equation will be equal to nl into p power 4 nl, and it will be equal to 8 and divided by 2l plus 1 minus 3 into me power 4 e power 8 divided by h4 into n4. So now we again come to the first order correction to energy, and we can put the value of E4 to the first order correction. It will be equal to E1R is equal to NLJ MJ into P4 NLJ into MJ. So into 1 over 8 ME cube C square. So now we can put the value of P4 and it will be equal to E1R is equal to 1 over 8 ME cube C square multiplied by ME4 e power 8 divided by h4 n4 into 8n divided by 2l plus 1 minus 3. So I can further simplify this equation. How I can simplify it? I can by multiplying and dividing by c square. So we can multiply and divide by c square. So the first order correction to energy will be equal to me4 e power 8 into c square divided by 8 me cube into c power 4 h4 into n4 multiplied by 8 and divided by 2l plus 1 minus 3. So here alpha is equal to e square divided by hc, and alpha 4 will be equal to e power 8 divided by c4 h4. So here the alpha, as we have already calculated in our previous lecture, is equal to the fine structure constant. It is also called as fine structure constant. So by replacing this term by alpha, so the first order correction to energy E1R, it will be equal to alpha 4 into me c square divided by 8 and 4 into 8 and divided by 2l plus 1 minus 3. So again I can write it like E1R is equal to alpha 4 En naught divided by 4n square into 8 and divided by 2l plus 1 minus 3. So this is the first order correction to energy. This is the first order correction to energy due to relativistic effect. Into the total Hamiltonian of hydrogen atom. So this relativistic correction for hydrogen atom as well as the spin orbit correction are of the order of 10 power minus 3 electron volt. It's just because alpha square into E and naught is of order of 10 power minus 3 electron volt. So this was all about the relativistic correction to the total Hamiltonian of hydrogen atom. So thanks for watching. So for more videos, subscribe our channel.